Hello, and welcome to our next set of stats notes. We are working on section 6.2. In the first section for chapter 6, we introduced the idea of finding the area under these normal distribution curves. We kind of showed how to use a table to do it, and then we showed how to use the calculator to get those values. In that section, we were always working with the standard normal distribution. The standard normal distribution is special because it's always centered at the mean of 0, so its mean is always 0, and it has a standard deviation of 1. And so we saw when we were inputting values in the calculator, we were always putting 0 in for the mean and 1 for the standard deviation. We can actually expand that, take this into more of a real-world, real-life application, and we can find the area under normal distributions even if they're not standardized. So we said the standardizing is where we make the mean 0 and the standard deviation 1. So all the problems in this section won't have that standardized property of having the mean be 0 and standard deviation be 1. And we'll show you again how to do it with the table and how to do it with the calculator. But I think you'll find that the calculator method is really easy. In fact, if you're using the calculator, this section is not going to feel that different mostly than the previous section. There'll be a lot of similarities. Excuse me. Okay, so we're going to start off. We can use z-scores like we learned about in the previous section. Remember the z-scores where we find the z-score by taking the value we're considering minus the mean and dividing it by the standard deviation. That was our formula for z-scores. And we can find the percentage or the area or the probability, whatever you want to call it, all different, different aspects of the same quantity within a specified range using usually a z-score or specified value. And they give you a procedure here, so this is kind of what you would go through. A lot of this is really going to help to make sure you're doing it correctly, making sure you double check your values, make sure they make sense. So it's good things to do, even though you might be able to do it without all these steps. First off, definitely sketch the normal distribution. I'm just drawing the curve and labeling the values you're looking for or that you know, marking the given values, that kind of thing, will definitely help you get a better idea about what you're doing. You always want to kind of shade the region you're looking for. It helps you think about the fact that the region's on the left or on the right side, whether you expect it to be big or small, that kind of thing. Since the values in this section are not going to be given as z-scores, they're going to be just regular numbers, we do need to convert these to z-scores if using the table. And we'll see that if you're using the table, you always have to use z-scores with the table. So we'll do that to use the table. And then once you have the z-score, we find the area. Again, this is if we're doing the table. I'll show you how to do it with the calculator where it's a little different. But if you're using a table, then you'd have to get the z-score and then find the area from the z-score on the table. So these two are really kind of for tables. And I'll show you how you can kind of skip them when you're doing the calculator method. So let's do one. We'll do it with the table, like I said, first. So we'll solve this problem and kind of see how it works. Okay, the heights of kids in school are normally distributed, so they have a normal distribution. You know, that's the L-shaped curve like this, with a mean of 50. Remember that mu is for mean, so that's telling us the middle number. So we can actually label that. That's a given. So we know that right in the middle of this table, right here in the middle, that is going to be 50 inches. That's the mean. It's always in the middle. And then it says it has a standard deviation of 10 inches. So standard deviation, again, that's a measure of spread. So if we go out like 1, 2, 3 standard deviations, and we say that's going to be most of the values, we'd be going out 10 inches in this case. So those are the important numbers to know. And then it wants us to find the probability, percentage, area, all of these, the same thing basically. The student has a height of less than 38 inches. So we're going for less than 38. So if I mark off 38, well, 38 is going to be smaller than 50. So it's going to be somewhere over here. Be a 38, and if we're looking for less than 38, we're looking for this much, 38 or less. So we kind of sketched our distribution, we marked the mean, we marked the value we're looking at, and in this case we shade the region that we're looking for to be less than 38. So this is the region we're looking for. So we're looking for this area, probability, percentage, all different names for that same part, but we're looking for that region. Okay, so now we kind of know what we're looking for this area, this region. Note that because this is less than half of the graph, we should expect this to be smaller than 50%. Kind of an obvious check, but if you do this wrong, you might get a number bigger than 50%. That'd be a way you know you did it wrong, because the middle, right here is the middle, I should have 50% on both sides. So if it's a little bit further over, like here, we're going to have less than 50%. Now that we have the values, we marked it off, we're looking at our region, we're going to convert the value they gave us, this 38, into a z-score. So we're doing it by hand with a table, so we use that z-score formula. So our z-score is going to be that value, 38, minus the mean, which is the 50 inches, that's the mean, divided by the 10 inches, which is the standard deviation, which goes on the bottom. So 38 minus 50 is 12, I believe. And then divide by 10. Oh, and it's a negative 12. Don't forget it's negative because 38 minus 50 is going to give me a negative. And so I end up getting negative 1.2. You can put that in your calculator. I just did it by hand because I picked easy numbers to make it so it wouldn't be too bad to do by hand. So that's my z-score. So our z-score is negative 1.2. Now again, using the table, using that z-score table we had, we want to make sure we're on the negative side because we're using a negative z-score. So this kind of shows how the z here is marked to the left of the middle. And so that's the same idea. So we're going to have that left of the middle over here. And we want to find negative 1.2. So negative 1 is going to be towards the bottom middle. So there's negative 1.2. And because this doesn't have any more to it, it's just negative 1.2, you could think of it as negative 1.20. And so we're going to go to find negative 1.2 and then 0. And so that's actually just that first number in that column. And it is 0.1151. So this gives us, from the chart, it's 0.1151. And that's the methodology if you want to do it the table. So we had to first take these given values and we had to standardize them, right? We had to turn them into the standard chart. This regular normal distribution has 50 inches in the middle. Well, when we standardize, we go back to that simple chart that has always 0 in the middle. And that's why we can use this table now, because we turned it into a z-score, and the z-scores you can use the table. I couldn't use the original 38 because there's no 38 on here. It only goes up to negative 3, of course. But when you turn it into a z-score, then it's going to fit on your table. So that would be our answer. Probability would be 0.1151 or 11.51%, right? If you wanted a percent version. So there's an 11% chance that someone in this school is going to have a height less than 38 inches. 11.5% of students are less than 38. The rest of the students are above that. Now, if you want to do this with a calculator, well, then we're going to use the normal CDF. It's the same function we used last time, so that's not any different. It's the same normal CDF. So we're still using normal CDF. The differences are now, instead of, we won't use the z-scores, we can just use the values that were provided. Lower in this case, we're going left forever, so there's no limit. It goes on forever this way. So we want to just pick a really, really small number so we don't, so we can have something on the bottom. And so we'll do something like negative 10 to the 99th, really small number. That's all this is. You could just write negative 100 with a bunch of zeros after it. This is just a fast way to do it. Next thing is the upper limit. The upper limit is where we stop. So we're stopping at 38. That's our upper limit. Now it's the mean, and because again, we're not working with the z-scores right now, we're just trying to do this with the numbers they gave us. We can just use the mean they gave us, which is 50, and the standard deviation they gave us, which is 10. So the cool thing is your calculator is smart enough that if you give it just the regular mean, the regular standard deviation, and the value you're given, without doing any work with z-scores at all, the calculator can use that information and get us the same area. So we're going to type that into our calculator. Remember to do this, we're going to hit second, and then this distribution, DISTR, that's the bars button, and then we're going to do the normal CDF. Always CDF. Remember, PDF just does a straight line and it doesn't do the shaded region. If you did PDF, you'd just get this bar and you wouldn't get the rest of the region. So we always do CDF to get everything from that value less. And everything from between 38 and negative 10 to the 99th is really small. So I type in my negative 10 to the 99th. My upper limit is going to be the 38. My mean now is going to be 50, so I'm going to change this. That's something you got to be careful when you get to the test for this section, because in section 6.1 you got to just keep leaving these as 0 and 1 for the mean and standard deviation. But now in this section we got to change these. We have to change the mean and standard deviation for these problems. And so when you're doing the test, you got to make sure you're always setting it right. If you're working with just regular numbers and not z-scores, you got to set the appropriate mean and standard deviation. If you're working with a z-score, the mean is always 0 and standard deviation is always 1. But in this case, our standard deviation is 10. So I'm going to type in 10 for our standard deviation. Again, I typed them in like this, but your calculator might have to type them in like that. It just depends on the calculator you have. That should give us the same area, and it did. It gave us 0.1150, but the 6 would tell us to round that up to a 1. So that would round, it would round to 0.1151. So it gave us the same value. So remember, you have to do the second and then do the DISTR button before you can find that normal CDF option. So for the rest of the section, if you want, you can just use the calculator to get these. You don't have to do it by hand, and that's pretty much what I'll do from here on out too. I'm going to still draw the chart so we can think about what's happening. So when we get an answer like 11%, we can see that that makes sense because this is not 50%, right? It's smaller, so 11% is smaller. It might look pretty big, but remember that most of the values are in the middle, so the stuff at the end is actually not that much. It's only 11% in this little tail because the rest of it's over here. Most of it's in the middle. Okay, let's try another one. Get some practice and get this idea down. Okay, so test scores for a state standardized test are normally distributed. So that's the big word we're looking for. Normally distributed just means it's going to have this shape. So it looks like this. They won't always give you the picture, but that's the word, just telling you that's what it looks like. Has a mean of 100. So remember, the mean is just telling you what the middle value is. So in this chart, 100's in the middle. And then a standard deviation of 18. So standard deviation, 18. And so using the symbols for these, remember that mean is mu, so mu would be 100, and sigma, the lowercase sigma, is the standard deviation, that would be 18. So they're just giving us those values. They want the percentage of observations that fall between 105 and 130. So now we're actually looking for between two numbers, between 105 and 130. So 105, it's going to be over here, so it's going to be like 105, 130 is going to be further over, right, 130. So if we mark off that region, we're looking for the shaded region between those values. That's what we're looking for, the values between 105 and 130. What percentage, what is the area, percentage, probability of this region? So they can ask for any one, right? They can ask for probability, they can ask for percentage, they could ask for the area of that region. They're all going to be basically the same value. Okay, so again, because we have the real numbers, and we have these mark-off numbers and stuff, we can use that normal CDF. That's not changing. It's going to be the normal CDF. As long as we're trying to find the area, this region, we're going to use normal CDF. This time, because they did give us a bottom number, we'll put that number first. You always start with the lowest number first. We'll put the 105, because it's our lower number first. And then we do have an upper number, so we put 130. So this time we didn't need that 10 to the 99th because they gave us both the bottom and the top. There's, both ends. And then again, the mean is actually 100 this time, right? The mean is our 100. Because they didn't give us z-scores, they gave us actual numbers. The 105, 130 are not z-scores, because of course z-scores are between 3 and -3. So these are way too big to be z-scores. And the standard deviation would be 18. So that's what we type in our calculator to get this answer. I'm going to type in, I'm going to do the second distribution, normal CDF. This time I'm going to clear out this -10 to the 99th. I'm going to put 105. 130 is the upper limit. 100 is the mean. And 18 standard deviation. So I get that in there. Again, if you have your calculator, you might have to type it in like this. If your calculator is different than mine. But that should give you your answer. So this one, the answer should be 0.3428, or about 34.28%, right? So if we think of that as a percentage or a decimal, they both work. So that's the area there. This area is going to be 34%. And that makes sense. Again, it's less than half. Here, 105 is close to 100, so we're kind of close to the middle. That's why this is still pretty big. When I'm shading this in, I didn't put these 105, 130 very specific values. So this picture might not be perfect, right? It might not look like 34%, but it does show me that this is going to be less than half, right? Because half would be from the 100 all the way out. And this is going to be just part of that. So I know right off the bat that this should be less than half. And it is, so that's a good sign. And that's what I'm something to be looking for. So there you go. So this is 34% in this region. So again, we use the mean they gave us, the standard deviation they gave us, and then the two end points, because it's one they wanted between. And when they give you between, that makes it pretty easy. You just put the first number, the smallest number is always first, and the bigger number. It should always be in that order for these two. It's always the lower, and then the upper. And that's the mean and the standard deviation. And again, 6.1, it was always 0 and 1 because we were working with z-scores. They wouldn't give us numbers like 105, 130. They would give us z-scores in the last section. Now they're giving us just regular numbers that are not z-scores. So now we're using the mean and standard deviation to go with that set of data. Okay, next page. Okay, so this is where we turn around and we go the other direction. So far, they've been giving us z-scores, values, and then asking for the range between or the range to one side, left or right. Now we're going to go the other way, so they're going to give us the area and ask us to find the values. So this is going backwards now. So I'll change colors just to kind of show that this is going backwards. So now we're finding values because we know the area. So instead of using ranges to find the percentage of values, we're going to work the problem the other way around. We're going to, given a specific area, so that gives us a percentage probability area, we're going to find the z-score and then go back and find the value. So this one, because of the way things work, and again, if we're doing it by hand, we'll have to go back and we'll have to find the z-score first and then find the value, kind of like we did on the first page. We end up finding the z-score first, just from the other direction. But again, once we get the calculator, we can kind of skip the z-scores again. We'll see that as we go. So first we'll sketch the curve again. It's always nice to have that curve there so you can look at it and figure out what you're doing. Shade the region that's known. So again, this time the region is actually the known area. So we actually know what the region's area is. And then we're going to go back and figure out the z-score and then finally the original value. So we'll use either a chart or technology to obtain the z-score and then use the z-score to find the original value. And we'll actually use the formula, the z-score formula, to do that. Okay, so let's look at an example. So here we go. We have a data set that has a mean of 100. So they're going to give us the mean again, because these are not standardized, they're not z-scores, so we have to have a mean because it's not just 0. The standard deviation is 5. That's the big difference here, is they're not just standard scores, so we have to know what the mean and standard deviation are. And they want us to find the 70th percentile. Remember that 70th percentile is a fancy way of saying that 70% is to the left. Because remember, percentile, that's percentage that's that much or below. So if I think about this, in the middle would be my 100. Remember that that's 50%, right? So if I want 70% to the left, I'm going to have to move further to the right to include more percent. Because here is 50%, so if I keep going up it, 55, 60, 65, 70, eventually I'll hit 70% somewhere over here. I don't know exactly where it is, but now this value is going to have this region, this big region. Excuse me, I got a lot of coughs today, sorry. This region is going to be 70%. That's what that region is going to be. So this region is going to be 70%, this percent to the left. We're looking for this value. It's not a z-score, we're actually looking for the x value, the number that goes with the mean of 100 and standard deviation of 5. It's not going to be a z-score. But before we can find it, first we do have to find the z-score. So what we're going to do is we're going to use the chart first. I'll show you with the chart. And we're going to look up 70% on the chart. Remember that the chart is always values to the left. So since the 70% is to the left, we're great to go. If they'd given us like the 30% over here, we'd have to subtract from 100 and figure out they were looking for the 70%. But since these hold the 70th percentile, we are looking for the 70% to be to the left. Okay, so I look at my chart, and at first I think, okay, can I use this side, the negative square side? Well, no, because we drew the picture and we saw that we actually have to be to the right of the middle. So our z-score should be positive. So we're not going to use the negative side, we're going to use the positive side. Because we want a chart that looks like this, where you can see the marked value is going to be over here, because more than 50% is to be to the left. So I'm looking for 70%, so now I've got the area. I'm going to look in the middle for that area, which 0.70 is somewhere between these two, and I look at that and I see this one's about 19, over, this one's about 15 under, so this one's actually a little bit closer. Between these two, 0.6985 and 7019, 6985 is actually a little bit closer, so we're going to go with 0.52. So 0.52, because that's that 0.6985, that's going to be our value. So use chart at 0.6985, because that's the closest to 0.70, and the z-score is 0.52. So 0.52 is our z-score. That's the closest thing we can get, so that's what we're using. Okay, so now that we have the z-score, we're not done, because they didn't ask for the z-score, it asked for the actual value. We want to find the 70th percentile. We want to find the number, this x value, that actually marks off 70%. So we're going to go back and we're going to have to use the z-score formula. And I mentioned the formula here, so I should write it down. The z-score formula, again, is x minus the mean divided by the standard deviation, right? That's the z-score formula. And this time we have the z, right? That's 0.52. We have the mean. The mean is 100. And the standard deviation is 5. What we're missing is the x. That's what we're trying to figure out. So we're going to have everything else. We're looking for x. So we have 0.52 for z equals x is what we're looking for, minus 100 is the mean, over sigma, standard deviation is 5. So now we have to solve this to figure out what x is. We're going to have to do a little bit of algebra, not too much. We're just going to first off undo this division by multiplying by 5. So we're going to do division by multiplying. So both sides we're going to multiply by 5. Cancel these. What is 5 times 0.52? So 5 times 0.52 gives me 2.6. So this side ends up being 2.6 equals x minus 100. And then undo subtraction, we're going to add 100 to both sides. We're going to get rid of this part. And so we get x, the value is going to be, well, 100 plus 2.6 is 102.6. So that's the value. Now stop and make sure it makes sense. This number should be bigger than 100, right? Because it's to the right of 100. If you get something less than 100 here, you know you made a mistake because you shouldn't be getting a value on this side and be able to get 70% to the left. You had to get over here where you can be all the way up here, so there's more below, so there's a big 70% in this box, or this area, this region. And so that's why x had to be something bigger. It had to be 102.6. You could double check this by going the other way. You could take this 102.6 and that mean of 100 and standard deviation of 5, throw it in your normal CDF, and see if it gives you 70%. And if it does, you did it right. Also, you can do what we just did here with the calculator instead. So instead of doing it with the chart, again, if you're comfortable with the chart and that's what you prefer to use, that's fine. But if you want to do this with a calculator, you're going to use the inverse norm option. So inverse norm, we saw that again, we saw that last section. It's just when you go backwards, when you take the area and you go back and find the, last time it was a z-score, now it's just going to be the value. It's not a z-score because, of course, 102 is not a z-score. It's just the number for this normal distribution. Okay, so inverse norm. We'll do inverse norm. So in norm. And then the area, which in this case is going to be the 70%, we're going to put in as 0.70, or you could just put 0.7 because the 0 doesn't really need, you don't really need it. The mean, which the mean in this case would be the 100. And the standard deviation, which is the given 5. So the standard deviation is 5. And so that's what we'll put in. Remember that this area is always to the left. So when we did this, we can use just 0.7 because it's to the left. But if we were looking, like if 0.7 is to the right, then we'd have to go subtract from 100. Since 0.7 is to the left, we're good just using it as is. But this area is always to the left. Okay, so that's what we type in. So type that in. Go to that second distribution or bars button, that one again. And we're going to go to inverse norm, which is option 3. Type in an area 0.7. Oh, I hit the wrong one. That's why it looks weird. If you hit the wrong button, you can get some weird stuff. I want inverse norm actually to hit inverse t. Inverse norm area 0.7. The mean is 100, right? Because that's given. The standard deviation is 5. That's given. Put it in there. Should type it in like that. Again, if your calculator doesn't, you can just type it in like that, and you get 102.6. And you'll see that's exactly what we got, right? If you round up 2 off, you get 102.6. So sometimes you can have a little bit of rounding difference between the table and the calculator, especially if you pick a number that's not quite as close. Like maybe you use the 0.53 instead of 0.52 because you didn't notice the 0.52 was a little bit closer. And so you might get a slightly different answer, and that can happen. With MyLab, you gotta be careful because sometimes a little bit difference in rounding could make you get it wrong. So that's something to really watch out for, is if you're rounding a little bit too much or in the wrong way. That's one nice thing about using the calculator, is you're going to have less rounding problems, I think. Okay, let's do one more of these and then we'll be done. Okay, the scores for a standardized test have a mean of 120, so they gave us the mean. So again, this section, because we're not working with z-scores, they always have to tell us the mean and standard deviation, partially because we actually have to use those to do these problems. So they gave us the mean of 120, so that's telling us where the middle is. Middle is 120. It's always nice to know where the middle is. Standard deviation of 14, so again, that's sigma, this would be mu. And they want to know both the 5th and 95th percentile, so the 5th and the 95th percentiles. So we're actually looking at two things. So the 5th percentile is going to be a region that only has 5% to the left. So it's going to be a pretty small piece, right? Because this area right here is going to be 0.05. 5th percentile is the same thing as 5% or 0.05. That's that region. The other one, I'm going to do a different color just to show this. The 95th percentile, that's going to be one where it's going to have 95% to the left. So most of it's going to be to the left. And if I think about this, if it has 95% to the left, well, then how much does it have to the right? Well, to the right, it's going to only have 5%, right? Because if you have 95% to the left, you're going to have 5% to the right, because 95 plus 5 gives you 100%. But this one, if I take this one and it goes all the way that way, that region is going to be this whole region, this whole thing, is going to be 95%, so 0.95. So we want to find both values. We want to find the 5% value and the 95% value. Well, to find the 5% value, because that's area to the left like this, we're just going to use that inverse norm again. So inverse norm. Area is 0.05, because that's the area to the left. The mean they gave us is 120, so that's our mean. And the standard deviation they gave us is 14. So I just punch that in the calculator, and it should give us the answer. Type in here, we can do second, and distribution, inverse norm. Area is going to be 0.05 because it's only 5%, so it's not very big. You know, that's why it's not even it's 0.05 because it's not like 5% or it's 5%, not 10% or 15%, so 0.05. Mean is 120. Standard deviation is 14. Paste. Oh, I'm in the wrong. I'm gonna quit out of that. Let's try that one more time because I was in the wrong spot. So inverse norm. 0.05, 120, 14. Oh, that's good. Hit paste. Enter, and I get 96.97. So again, that's the value. It's not a percentage. That's the value right here. So this value is 96.97. Now, when we were working with z-scores, we had that nice thing where we could, reflect. So if you had like the z-score was negative 1 point or negative 1.2, then you could have a matchy z-score on the other side that'd be positive 1.2. And the problem with these values that are not z-scores, these are kind of your x values, not your z-scores, is now you can't reflect. So I can't say, oh, this one's negative 96, that's going to be positive 96. Well, it doesn't work that way because this is 96. This is going to be something bigger than 120. So when you're working with z-scores, you can always reflect because the middle was at 0. When you're working with any other normal distribution that's not a z-score, not a standard normal distribution, you don't have 0 at the middle anymore. So I can't just take this value and flip it over and get this value because you notice that those are both 0.05. If it was z-scores, you could do that. But if they're not z-scores, if you're working with just regular values like this, you're going to have to do it separately. You get a different answer. Now, one thing that will be true is that because this is 0.05 and that's 0.5, these will be the same distance from 120. So whatever this distance is, that distance will be the same because they'll both be the same distance from the middle to get those same areas to the left and the right. But to do that, I'm going to have to go ahead and just use another calculator option. So this one gave us 96.97. The next one, I'm going to do another inverse norm, but this time I want that 95% to the left. So I'm going to do 0.95. Still 120, still 14, and get this other value, whatever this value is. Okay, type that in. So we get second distribution, inverse norm, 0.95, still 120, still 14, and paste. And enter, and we get 143. So again, that's bigger, so it's over here, 143.03 if you round it. And you can see how this is fairly equally distanced, right? This one you go down about not quite 30. This one you go up not quite 30 because 50 would be 30 up. So this one it's like about 23 difference. So this is 23 down. This is 23 up. So these are equally distanced. If you took these and subtracted, this distance would be, this part and this part would be the same. If you found the distances here, that'd be the value for here. So the other one is going to be 143.03. So those would be the two values that mark off the 5 percentile and the 95 percentile. Okay, so again, this section's a lot like 6.1, The main difference here, because we're still using the same functions and everything, but the main difference here is we're not working with the z-scores per se. You can if you use the table, right? You saw how we can use the z-scores as an intermediate step. But if you use the calculator, you bypass the z-scores altogether because you can just give it the mean and the standard deviation of your normal distribution. You know, it's not standardized, and it can still give you those values. Again, these values, because it's not z-scores, they're going to be whatever, you know, makes sense on this graph down here. Again, mean should always be in the middle, so 120 should be in the middle. It's helpful to know about that so we can think about these other values if they make sense or not. Okay, so that's it for 6.2. So I'm going to leave you there, and we'll see you on the next thing.